this video we'll be looking at the typical design and construction of a rigid pavement. The most common rigid pavement is a reinforced or unreinforced concrete slab. This photo shows a concrete pavement for a highway. The surface is timed to provide a non-skid finish or to provide good adhesion with an asphaltic concrete surfacing yet to be applied. The subgrade under a rigid pavement does not need to be so strong as the traffic loads are more evenly distributed across the whole slab, so the pressure on the subgrade is less. This photo shows a concrete road under construction using mainly manual labour. The concrete is being spread by hand, which is what the workers with rakes are doing. In front of them is a screed sitting on wooden forms at each side of the road. The formwork contains the sides of the concrete, while the tops of the formwork are set at the level of the road. So all you need to do is get the correct level is to run the screed along the top. I'm assuming they are constructing one side of the road and that the photo is taken from the centre line of the road. You can see a little bit of the wooden form in the bottom of the photo. This form will be slightly higher than the form on the outside of the road to provide the camber required to drain the road surface. Note that the screed is a truss beam, which is what is required to span the whole width of the road without sagging. A sag in the screed would cause a depression in the bottom of the road, which would pond water. The concrete needs to be vibrated in place to remove air entrapped in the concrete, which would otherwise cause voids, and to create a dense, strong concrete structure. This may be done with handheld vibrators, or the screed may have a vibration unit connected to it to vibrate the screed, which may be what the unit on top of the screed is in the background. This photo shows a concrete paving machine that automates the laying of a concrete road. The paver has its own engine which powers the tracks and the concrete laying machinery, so once set up, the paver just trundles along on its tracks laying the road. The paver has laid the material in the foreground and is moving away from the camera. Note the concrete is a special dense mix which stands up on its own, so formwork is not required. In this case the road does not seem to have any reinforcing, and this is common with concrete roads, as the main stresses on the slab are compressive, which can be taken by concrete alone if the road is thick enough. However, there needs to be an allowance for expansion of the concrete, and expansion joints may be cut into the concrete after it is set. Concrete trucks deliver concrete to the site and discharge into the hopper on the far side of the paver. The concrete is distributed across the width of the road and then laid in even layer on the road. The depth of the layer can be set to accommodate the different depths. The screed at the back, which is facing us, provides a final trim of the surface and smooths it. The fabric at the back is hessian that is used to provide a smooth finish. The hessian is often moved from side to side as the machine moves forward to provide a wavy pattern for increased traction. Rigid pavements are not used much in New Zealand, so we will not look at them further in this course. If you are interested in learning more about rigid pavement, then I suggest you refer to the Austroads Guide to Paving Technology, Parts 2 and Part 4. The link to the Austroads site is in the resources section. There are two other variations on rigid pavement that should be mentioned in this video. The first is structural asphalt. As we have seen, asphaltic concrete laid in layers up to 50mm is a common surfacing. At this thickness, the structural support provided by the asphaltic concrete is not considered significant. However, thicker layers of asphaltic concrete can provide structural support. Structural asphalt involves laying asphaltic concrete in layers that are over 100mm thick. The asphaltic concrete used may be a denser, stronger mix of AC, such as Mix 40 or stone mastic asphalt. We will look at these types of asphalt in later videos. Structural asphalt is still quite flexible and not as rigid as concrete slabs, so this type of pavement is often called a semi-rigid pavement. The flexibility means it can tolerate ground movements better than concrete while still providing structural support. The main problem is that it is very expensive. This photo shows structural asphalt being laid on the Hamilton Expressway. Note they are using a conventional paving machine but laying a thick layer of asphaltic concrete. While they are not strictly roads, it is worth looking at driveways and footpaths as they are commonly used in New Zealand and are concrete pavements. Most councils have standard designs for driveways and footpaths in the area. There is usually little design required. This drawing extract is from Auckland Transport's Code of Practice. It shows a section through a typical residential driveway crossing a footpath. You can see it is a 150mm thick reinforced concrete slab on a 100mm thick AP40 base course. Most driveways to single properties have no reinforcing. However, this drive has reinforcing as it serves over 4 properties and therefore has more traffic loading. Note also that the design specifies a subgrade with a CBR of 3 or above. CBR stands for California Bearing Ratio, and it is a measure of the strength of the subgrade. A CBR of 3 is a soft soil. The standard design for access to commercial and industrial properties has a 200mm thick reinforced concrete slab. The extra thickness is to allow for heavier vehicles and more traffic which would access an industrial or commercial property. The Code of Practice also sets out the required dimensions of the driveways.